welcome back. I'm your friend Inside. So since I have determined to take an exam in the next year, so I need to get started to learn some mathematics and English. And as you know, in the previous video, I just did a test about myself of how good my English actually is, and it turns out to be not that good. For this time, I'll continue to do a test. The subject is mathematics, and I should be honest. Let me tell you the truth. The truth is that I was very bad at the mathematics back in the school. So you may get disappointed later or in the future about my mathematics skills. But that's fine. Since my mathematics skills is quite bad, that's why I need to improve it. If it's good enough, why I would do anything about it. So let's get started. Generally, I learn math from those Chinese resources. Why? Because the Chinese education system intended to make a Chinese version of knowledge. You know, they normally just want to say how good you can be if they give you some Chinese questions. They won't write the English version because they don't speak that. But for me, since I always want to share my knowledge with the whole world, with everyone, including you, so I have no choice but to translate those Chinese words into English so you can understand properly. Okay, let's get started. And for this one, but luckily for us, the mathematics itself, those equations, those symbols, they are the same. Almost every one of us use the same symbols to describe the same things. So we can do this together. For this question, let's say for this question, it asks us to do a calculation about the limits of this equation. And as you can say, at the first I did some attempts and it turns out to be wrong. So that's why I made a mark like this. And at the right side, as you can say, this is the right answers. I tested it here to show me the right answer and do some understanding on that equations. And this is what I get from the right answers. I start to thinking about why they could get the right answer, which is 4 over 3. But for now, I just want to copy this equation and start a new page. Paste the question here. We're gonna try to solve this problem again totally by ourselves. Okay, let's get started. First, let me rewrite these equations for you. I should try to say something, right? As I write that equation. So we're gonna try to solve a limit when x approaching to 0, and that equation is 1 over sine x squared minus x squared divided by cosine x squared. So this is the original equation. We need to get the limit of that equation. How can we do that? At the first, as I can say, we get basically 2 items, the first one and the second one. For this case, for each of them, if the x approaching to 0, this equation would be invalid, so it cannot be x for now. The x cannot be 0 for now. And for the second item here, if the x approaches to 0, if this one approaches to 0, this item would be also invalid, so we cannot just simply replace the x with the 0 for now. We cannot do that. We need to do some changes to the equation. So how can we do that? We could probably do this. Let's say we want to merge the 2 equations together. So we say sine x squared times x squared divided by x squared. Why do this? As you can see here, it's something like this. X squared divided by x squared is equal to 1. So the equation here is exactly equal to the previous one. Minus sine x squared times x squared, then cosine x squared times sine x squared. Now we could easily merge them together since they have the same divider. So sine x squared times x squared divided by x squared minus sine x squared times cosine x squared. And for this case, we still cannot just let the x equal to 0. Why? Because if we let the x equal to 0, then this would be 0. If the divider equal to 0, this equation would be invalid. So that's not allowed in the mathematics. We cannot do that right now. We need to simplify this equation a bit more. But how can we do that? As you can see here, we got the sine x squared times cosine x squared. For this one, since we got an equation here, it's called sine 2x equal to 2 times sine x times cosine x. We copy that equation to here. Okay, now let's think about this. The sine x squared times cosine x squared will be just equal to sine x times cosine x squared together squared. Then for this equation, we could change the left side and the right side a little bit. For example, now we can say sine 2x over 2 equal to sine x times cosine x. Did you find the two sentences, or as I could say, it's just a string? But in the mathematics, it's probably some symbols, as I would say. This is identically equal to this part. So since they are just looks like the same thing, we could just do this. We say sine 2x over 2 squared equal to sine x times cosine x squared. So now one problem just solved. We can refactor our equation, or for a little bit, we could say x squared minus 2 squared divided by sine 2x squared. Then we keep the divider right in there. We could simplify this equation a little bit more. We could say x squared minus 1 over 4 times sine 2x squared over sine x squared times x squared. Okay, for now, as you can see, if we let the x equal to 0, this would be still invalued, and we are running out of ways because we have already used some simple transformations in the mathematics. And even if we did that, this equation still cannot be simply solved. So we need to find another way. And for this case, here we got a rule called the Liouville's rules. For this rule, it is said that if the equation looks like 0 over 0, if we let the x equal to 0, then the equation looks like 0 over 0. Then we could use this rule. What this rule says is that if this equation looks like this, then we can get the limit. We can use the derivative of that equation. In other words, okay, let me copy it here. Okay, in other words, if we can get the limits of its derivatives alternative or equations, then we can get the original limit because they are equal. So for now, for each part, the first part and the second part, we need to get its derivative. Okay, let's do it. For the first part, let me write it very quickly. If we want to get its derivative, we could say for the x squared, we could say 2 times x2 minus 1 minus 1 over 4 times the derivative of sine x. The derivative of sine x is cosine x. So we could say before we do that, as you can see here, we got a squared symbol. So for the x to the power of n, if we want to get that stuff's derivative, we would use this method. So in other words, we're gonna say times 2 times sine 2x 2 minus 1, which is 1. Then we handle the sine x itself. That will be cosine 2x. Then times 2 times x derivative, which is 2. Okay, for this one, let's simplify it for a little bit. That'll be 2 times x minus. Those things are cancelled out. So we have left sine 2x times cosine 2x. In the end, we have left 2x minus sine 2x times cosine 2x. Now for this one, we also need to get the derivative of it. So sine x squared times x squared, we want to get the derivative of it. That would be 2 times sine x times cosine x. I suddenly realized that this equation is just too complicated. If you want to get it right, for example, if you get the number like this, it will be equal to something like this, and it's just too complicated. So we need to simplify it for a little bit first. How can we do that? Here we get another method for it. That is sine x would be just equal to x, or approximately equal to x, if the x is approaching to 0. So for this equation, it will become x squared times x squared, which is x to the power of 4. And for this one, it can be quite simple. X to the power of 4. If we want to get its derivative, we could say 4 times x to the power of 3. Now let us go on with our calculations. We say limit when x approaching to 0, the first part now becomes 2x minus sine 2x times cosine 2x, and the second part now becomes 4 times x to the power of 3. We want to get the limitation of this. Apparently this is still unsolvable. We still have to do some simplify. How can we do that? Now we get a part of that equation equal to this, and this looks familiar. This is just something that we made before. Okay, it's just looks like this. I don't know if you have noticed that or not, but for now the r var becomes to 2x. So in the end, this equation could be something like this: sine of 2 times 2x divided by 2 would be equal to sine 2x times cosine 2x. So we will get something like this in here. This thing would be equal to 1/4 times sine 4x. Okay, let's write it down. Limits when x approaching to 0, 2x minus 1/4 times sine 4x over 4 times x to the power of 3. For this one, what do you think? Still, I cannot just simply let the x equal to 0. That would be invalid for this question. So that would let this question invalid. So we will again use L'Hopital's rule. First we need to get the first part derivative. So let's go. 2x minus this sine 4x derivative. Okay, we want to get its derivative. So that would be equal to 2 minus 1/4 times cosine 4x times 4. The 1/4 times 4 equal to 1, so it's cancelled out. In the end, what we left is 2 minus cosine 4x. So now the first part becomes 2 minus cosine 4x, and the second part I can just write the answers here. 4 times 3 times x squared. Let's go on. So now it becomes this: 12 times x squared 2 minus cosine 4x. For this one, you would simply notice that it's not solvable, but it goes through a lot of simplifies. It's already simplified a lot of, but it's not it cannot match the original correct answer, because here we got an argument wrong. 1/2. The original one is 1/2, but we got 1/4. Where it goes wrong? Okay, for this step we are right, but in the next one we are wrong. We need to get the derivative of this. Oh, let's say at the beginning we got 1/4 times 2 minus 1 sine 2x and cosine 2x times 2. I think this is right. It's all cancelled out. Okay, here's where we got wrong. For this one, sine 2x times cosine 2x should be equal to 1/2 times sine 4x, but what I have wrote is 1/4. There should be 2. So if that's 2, here should be 2 minus 1/2 cosine 4x. Then for this one, we still just say 2 minus 1/2 cosine 4x. Okay, but now we can at least for each one we divided by 2. So in the end, we could get limits of sine approaching to x approaching to 0, 1 minus cosine 4x divided by 6 times x squared. For this stuff, now I see I saw another pattern. I have 1 minus cosine x. For this pattern, we got another approximately equation like this: 1 minus cosine x approximately equal to x squared over 2. So let me copy it here, and I'm gonna show you how I did that transformation. For now, it's 1 minus cosine 4x. It should be approximately equal to 2 divided by 4x squared. So now the original equation becomes 16 times x over 2. If we simplify it, it will be 8 times x. So for the first part, should be, let's write it more specific, something like this: times x squared over 6 times x squared. Then we go on, we write another assumption, not assumption, we write another equation. So in the end, it could be something like this. I could write this all day, this simple calculation. For each part, we divide it by 2, then it will become 4/3. Let's say if this is the right answer. Okay, this is the right answer, 4/3. Basically this is how we solve Chinese mathematical equations. As you can see, it's quite long. I don't know why those people would ever wanna do this, because it seems like useless, you know. It does no good in real life, as I can see. You probably will never make such a thing in real life. But anyway, that's how the Chinese education system tests their students. They make questions like this. Okay, that's today's mathematics attention. I'll see you in the next one. Bye.